Assalamualaikum everyone. How you guys doing? Hope you are staying in and staying safe and doing great. Okay, so today we're going to continue with our lecture on fluid flow in food processing. Previously, before the MCO, we've covered the initial part of characterizing the fluid that include the type of fluid and a little bit of introduction to Reynolds number and all the important factors that may influence the fluid flow of your process. Okay, so today we're going to continue to characterize in terms of the means of transporting the fluid. So we're going to look, in short, we're going to actually look the pipeline system for transporting liquid food. Okay, the means that I meant is pump. Begin by looking into this simple sample of process flow diagram. So in this flow diagram, you can see the full stream and piping system involved in producing orange juice from start materials up to packaging where the final goods are. Okay, so this system, the whole processes will involve few unit operations, and as you can see here, we do have extraction, whereby you're going to have two streams, that is liquid as well as solid. So for this liquid that has been extracted to be transported to the next unit operation, that is filtration, they will need a pump. So here you can see in this simple process, it involves three units of pump. 1, 2, and 3. So these three pumps are essential for the transportation of fluid. Without it, then you will face challenges to transport your fluid from one point to another. So this is just a simple introduction. So now we're going to proceed to understand how we can characterize, size, and select the right pump for your processes for different. Okay, so let's begin and look into the key factors that will influence and impact the fluid flow. And here is a summary of it. And this can serve as a checklist for you to check your understanding towards the end of this session or this chapter, to evaluate your understanding about pump. Right, so what you will need to know is, for transporting the fluid, it is going to be influenced by, first is pipes or ducts. So pipes, what is pipes and what is ducts? We say as pipes if it's a circular and if it's not circular, it is ducts. Okay, the term is ducts. And another factor that will influence is the type of fluid. And this you already learned about it, that is Newtonian or non-Newtonian. Next is fittings. Fittings is a connection between the pipes. So for example, elbow, T, and valve. Elbow is the 90 degree one. T, we will have shape three junction here. Okay, these are the factors that will influence their fluid flow. Right, so from the types of fluid, we know that to characterize the type of fluid, we need to calculate the Reynolds number to characterize it into laminar, turbulent, as well as transition. Alright, okay, and once when you have a flow, then you will have friction, whereby the fluid or flow will drag across the pipe, causing loss in energy or pressure. Okay, so for fanning factor, to understand is the mean velocity, equivalent length, and Moody chart. So the three of this we already covered during our previous class. Okay, next, once we understand all of this, we can go into this to get the energy for pump. So they will relate to the Bernoulli equation. Okay, when we talk about heat flow, Bernoulli equation is the best principle to elaborate on it. Okay, once we got the energy for energy for pump, then we can do pump selection or sizing, and important some of few terms that relate to this pump selection of NPSH as well as pump head. Both we're going to describe it further in the next slide. This is net positive suction head. You will see a lot of this word, that is head. So what does head mean? Head is the height at which a pump can reach, or the ability of the pump to deliver flow at required or desired level. Okay.